All right. Hello, folks. This is your first assignment in Chapter 7. Let me get to my pen. Oh, let's be blue. All right, so we're talking about circular motion. And in part of the circular motion, centripetal acceleration, or centripetal. So what we mean by that is basically the acceleration the object has as it's spinning around. So let's take apart this question. As you see here, the most violent part of a hurricane is the edge of the eye. The eye wall have winds up to 300 kilometers per hour. Okay. All that is background. Remember, what we do here is we take some of this and we're setting up the situation or the experiment. We're just saying, hey, this is the violent part. This is where the winds go. Now, if we continue on the next sentence, suppose winds in the hurricane eye wall have a tangential speed of 62.2 meters per second. Now, this is not velocity, because we're just looking at speed. When we're looking at tangential speed, as I'm going to say in the lecture, it's going to spin. It's always changing direction. But we know that the speed portion of the velocity is constant. So there's speed. The eye wall is 25 kilometers away from the center, so we have a distance, or r, because, as I will explain in a minute. So what's the magnitude of the particles in the eye wall? Oops, let me go back, 82.2 meters per second. That's the tangential speed. And we're at 25 kilometers away from the center. All right, so what's happening is that here's the equation we're going to use. The centripetal acceleration is equal to velocity squared over r. And we've got to make sure that all the units are correct, guys. So what we have is that we have the hurricane, it spins, and in the middle we have the eye. Here's the radius. And this is where everything's going the fastest. So as the storm is going over, say, Florida, they're going to get battered, and the intensity of the winds are going to get high until it hits to the wall. Then as soon as that eye passes the town, it gets quiet. Then they're going to get battered again on this side. So how much is the acceleration? Meters per second, this is fine. This we need in kilometers. Excuse me, into meters. Change kilometers to meters, so that's going to be 25,000. So the acceleration is going to be v squared, so 82.2 squared. And I missed that. Over 25,000, excuse me. Now, if we look at the units, velocity is meters per second. And we're going to square those, so that's meters squared over second squared. Then we're going to divide by a meter. So one of the meters cancel, and now we've got meters per second squared, which is acceleration. So let's go ahead and calculate this. Acceleration, 82.2. We're going to square it. If I can hit the right buttons correctly. So that gives me 6,756.84 divided by 25,000. So acceleration is going to be 0.27 meters per second squared. So that's the acceleration it's seeing as these particles are moving around the eye. Now, this acceleration means this is how fast it's changing directions. So it's spinning, and the acceleration, it's not that the tangential speed is changing, but the direction is changing at this acceleration. I hope that all makes sense. Again, reread my lectures, and guys, have a good night.